Okay, let's try this last question here. It says the parabola intersects the x-axis at A and B. At A and B, so those are x-intercepts. Determine the length of A and B. Well, first, let's just figure out what these points are. And we've got the function, don't we? Yeah, because we worked it out in the last question. It's y equals x squared plus 3x plus 2. We want to figure out the x-intercepts. We let y equal 0. We factor this. We get x plus 1 times x plus 2. That works. So x is minus 1. So a is minus 1. And b is minus 2. Well, I'm calling this one a and this one b. But anyway you look at it, from minus 1 to minus 2, the distance is 1. So there you go. That's it. You could use the distance formula. You don't need to. From minus 2 to minus 1, or minus 1 to minus 2, the distance, the length, is 1. Okay, let's try 6.5. Now, f of x is reflected in the x-axis. Determine its new equation. Do you know this is the easiest thing in the world if you remember back to grade 8 or 9, to grade 9. To reflect in the x-axis, all you do is change the y from positive to negative, or change the sign of the y value, and that's it. In fact, there's a map like this. If you want to reflect in the x-axis, all you do is take the y and take the negative, whatever that y value is, and it'll always work. So how do we do that? We take the equation, and instead of y equals x squared plus 3x, we just make y negative. But we want to put it in the right form, so we multiply everything by a negative 1, and there's our new reflected equation. Y equals minus x squared minus 3x minus 2. And here's the last question. Let's see, I can't remember what it is. Oh, determine the values of k for which f of x equals k has equal roots. Equal roots is another way of saying, you use the quadratic formula and you go plus or minus 0, you get one answer. It's when you have one solution, just one solution. So we're looking at, see this dotted line here cutting across? That's, I forget what the value of that is. Oh, it's 8, isn't it? Well, if that place there, if f of x was equal to 8, look, you'd have two roots there. But we want to figure out this value here that has just one root, which is another way of saying equal roots. So how are we going to figure out t? Well, we need the axis of symmetry, and then we take that x value, put it into the formula, we'll get the y value, the k value that we need. That's where it's only going to hit once, when f of x equals that number, the y coordinate right there. So equal roots means that one solution right there. That's what I'm talking about. Well, how do we get the axis of symmetry? Well, we know it's minus 1 and minus 2. See how you keep using the thing from before to answer this? Minus 1 plus minus 2 divided by 2. There's the x-coordinate of the axis of symmetry that's cutting right through this parabola. Now, all we do is take that minus 3 over 2 and put it into this function here. Or let's put it into this one, even easier. Well, I put it into this one. It's all right. I get minus a quarter, which looks about right. Minus a quarter. Well, that's the k value. If f of x equaled minus a quarter, y equals minus a quarter, that's a horizontal line right there. It's only going to have one solution, or equal roots. So that's why the answer is k equals 1 minus a quarter. That's the place where it's got equal roots.